Good morning, dear students. I extend a warm welcome to you to this bridge course session, children. Today we are going to discuss about the terms and the basics related to circle, children. Number of circles I have drawn on the board because the shape of the circle is part and parcel of our life. Most of the things we use which are in circular shape, beginning from the wheels. The circle is a set of points which are all at equidistant from a fixed point. We call this as a circle. The fixed point is called as center of the circle. Center of the circle. Then this boundary, innumerable number of points lie on this boundary, children, and these points which are all equidistant from the center. This is the definition of the circle. Then this boundary, we call it as circumference of the circle. It is another term for perimeter, children. Circumference of the circle. This is the center of the circle, then this becomes circumference. Circumference of the circle is calculated by using the formula 2 pi r. If the radius of the circle is about 7 centimeters, then calculate the circumference. If r is equal to 7 centimeters, circumference is equal to formula 2 pi r, which is equal to 2 into 22 by 7 into radius 7, 7 cancel, okay, 44 centimeters. This is regarding circumference of the circle. This is how we calculate. If you want to calculate area of the circle, then we have the formula, children. Area of the circle, that all of you know that it is pi r square. Pi is 22 by 7. R square is 7 into 7. Cancels. Then 4, 5, 15 centimeters square. This is how we calculate area of the circle. So, I have introduced you, or I have reversed you two formula part regarding the circle. Center of the circle, circumference is nothing but 2 pi r. If you want to calculate area, how much area it has, okay, then that can be calculated likewise. Then the terms related to the circle. Center of the circle, this is radius, circumference. Innumerable number of radii can be drawn in a circle. Similarly, one more term, let me revise, that all of you know that it is a chord. Infinite number of chords can be drawn to a circle. All the chords are not equal, but all the radii are equal. Wherever you draw any number of radii, they will be equal. But chords are not equal. Chords, line segment joining any 2 points on the circumference of the circle. Then, if a chord, this is a chord, we know, a chord which passes through the center of the circle, we call that as diameter. Diameter has got 2 radii, children, which all of us know. D is equal to twice the radius. All the diameters are equal, innumerable, infinite number of diameters can be drawn in a circle. All the diameters are equal. The biggest chord is the diameter. Then, let me take a part of it, children. See, this is the part that I take from here to here. A, B, let me take this as X. This is the part I take. We call this as arc, children. Arc, part of a circle. Using compasses, pair of compasses, we draw arc. See, keeping at this, we draw the arc. This is an arc. If we extend it, it becomes a circle. So therefore, arc is a part of a circle. Arc is represented AXB, likewise children. Using three letters, we represent an arc. This is a smaller arc, therefore we call this as minor arc. The remaining becomes major arc. AYB becomes major arc. Radius, chord, diameter, arc, minor arc, major arc. Next, let us consider. This is a chord, children. This is the center of the circle. So this part is an arc. Then we have an area over here. We call this as segment, children. Segment. That all of you know that. It is an area enclosed between an arc and a chord. On the rotation part we call that as a segment. Okay? Area enclosed by a chord and an arc is called segment. This is a smaller segment. This is bigger segment. This part. Therefore, this becomes major segment. This becomes minor segment. This is a diameter which divides the circle into two equal parts, congruent parts, you can say. So each part we call it as a half circle or semicircle. Semicircle. This is half circle. Okay, semicircle. Then, if we look into the angles property, children, angles in the same segment are equal. This is minor segment, major segment. Okay, let me take this diagrammatic part. See, let me draw two angles. This is 40, then let me leave that as. What will be the value of x over here? The answer comes as 40. Reason, children, angles in the same segment are equal. One more, likewise. This is also will be equal to 40. So the first property regarding angles, children, angles in the same segment, whichever the number of angles that come under this segment, all the measures will be same or equal. Therefore, 40, 40, 40. Reason, angles in the same segment are equal. Then the second point, these angles are which are there in the major segment. So the angles property 2. Angles in the major segment will be acute in nature. Acute, children. Acute means we know that less than 90 degree. You can draw and check, children. Angles in the major segment will be acute in nature. Then angles in the minor segment, likewise. If you check this angle, definitely this will be obtuse angle, children. Angles in the minor segment will be obtuse, which means the measure of this angle will be definitely more than 90 degree, children. This will be definitely less than 90. So all these angles will be equal. Similarly, the number of angles which are drawn in this segment will also be equal because of the first property. Angles in the same segment are equal. But the angles in the minor segment will be obtuse angle. Angles in the minor segment will be acute in nature. Therefore, the third property, angles property, angles in the semicircle likewise. The question comes, A, B, C. What is the measure of angle C? Angle C will be 90 degree, children. Angles in the semicircle are right angle. Right angle. Next question, children. It may be like this. Angle A is 40 degree. Find the measure of angle B. Obviously, this will become 50 degree because we know that some of the three angles of a triangle is 180 degree. This is 90 degree. Okay? This will not be mentioned as a right angle, children. It is understood. This is 90. The remaining 90 degrees there in that 40. Therefore, this will become 50 degree. Likewise, we have to calculate and say. So, the first property, angles in the same segment are equal. Second one, angles in the major segment are acute. Angles in the minor segment are obtuse. The fourth one, angles in the semicircle are right angle. Then, one more term, children. This is the center of the circle. This is a chord I have drawn. Center of the circle, AB is a chord. Now, children, let me draw a line from center to the chord. We call this as distance from center to the chord, which means, children, it is perpendicular distance, remember. Therefore, this is OP is nothing but perpendicular distance from the center to the chord. So, this perpendicular drawn from the center to the chord bisects the chord. If the chord, which is about 10 centimeters, children, each segment will be 5, 5. If it is 8, it will become 4, 4. The property, remember, perpendicular drawn from the center to the chord bisects the chord. Okay? Then, if a question is like this, children. Okay? This is 5 centimeter. This is 3 centimeter. Find or calculate the value of AB or calculate the value of AP. This is how question can be asked, children. We must be in the position to calculate this. The radius is given, perpendicular distance is given. Perpendicular distance, I have already told you, the distance from the center to the chord is known as perpendicular distance. Okay? Then the perpendicular distance, perpendicular drawn from the center to the chord bisects the chord, which divides this point, divides this AB into two equal parts. Here, children, we come across a right angled triangle. Regarding right angled triangle, the longest side is given by the name called hypotenuse, which all of you know that. Hypotenuse. Hypotenuse. Okay? What is so special about this? Hypotenuse is the longest side in any right angle triangle. Where it lies then? It lies opposite to 90 degree. 90 degree opposite. It lies. Then, based on a right angled triangle, we have a theorem called Pythagoras theorem. In your 10th standard, you are going to study in detail about this theorem, children. The Pythagorean, the property that we are going to use to calculate the area of this, children. How do we calculate? See children, in triangle AOB, this is 90 degree. Therefore, there is a particular rule which is given by Pythagoras. What is that rule? The square of the hypotenuse will be equal to sum of the squares of other two sides. Which means children, AB square plus PO square is equal to AO square. This is nothing but Pythagoras rule. Squares of sum of the two sides of the triangle is equal to square of another triangle, another side of the triangle. This is about the rule. Let me substitute. AB square we do not know. X square. PO square is 3. 3 square becomes 9 is equal to AO square. This is 5. 5 square becomes 25 children. Therefore, X square will be equal to 25 minus 9 because of transposition. When a term gets transposed, its sign changes. X square is equal to 16. Therefore, the square, let me take out the square, therefore it becomes square root. Is square tegre square root agate, cube tegre cube root. Okay? Therefore, x will be equal to its value 4 centimeter. If AB is 4, then PB will also become 4 children. Okay, this is about a small basic that we need to know. The last part of this triangle, this circle children. See, this is radius children. This is the center of the circle. Let me draw one more radii over here children. One more radius. Okay, we have an area over here. This looks like a piece of cake children. So this part segment we have a special name called sector. Minor sector, this is major sector. Okay, in most of the round cakes, if we ask it for a piece, then this is the shape that we are going to get the cake children. This is nothing but a sector, remember. How do we define this children? This is the area enclosed by two radii and an arc. The area enclosed by two radii and an arc is called as sector. Sector. Regarding this, we have a separate lesson in your 10th standard children. We are going to learn in detail. Then, one more concept children. Let me draw two chords children. One is here, another one is here. If the chords are equal, then their perpendicular distances will also be equal. Remember, chords AB, one more CD. Chords AB is 10 centimeter, CD is also 10 centimeters. If chords are equal, then calculate this distance children. We know that this is perpendicular distance. The perpendicular drawn from the center to the chord. Okay? Similarly, this distance children. Okay? These distances, perpendicular distances will be equal. On the other way children, if the perpendicular distances are equal, then chords will also be equal. Okay? These are all certain basics and the revision part that I tried to do it children. Many of you will be knowing the terms as well as the content part that I have done it. Take this as a revision part children. This will be helpful when the lesson that comes as circles children. Next, we are going to discuss regarding surface area and volume children.